Hello YouTube, welcome back to my channel. So in today's tutorial we are going to go into concurrency in Python, concurrency. So we're going to series, this is going to be a series, so I'm going to be releasing videos as we go along and learn the different concepts involved in concurrency in Python. So this is going to be the first video, and the first video will talk about the basics and mostly the theory, and then later on we'll proceed as we go along. So let's get started. So the first thing you might ask yourself, what's concurrency in Python? So concurrency basically means, from a dictionary definition, it means simultaneously occurring. So when things are occurring simultaneously at the same time, that's what we call concurrency in Python. In Python, these tasks that occur at the same time simultaneously, these tasks are called tasks, threads, and processes. So this sentence might be a bit confusing because I said task here, and then down here I'm also saying task again. Don't worry, we'll explain this furthermore as we go along. Okay. So now that you know what concurrency is, we say that about processes that occur simultaneously in Python can be called thread, can be called tasks, thread, and processes. So are these concepts the same? Well, at a high level, tasks, threads, and processes appear to be the same, but if you take a deeper dive and look at them at a deeper level, they actually happen to be different concepts, and we'll see this as we go along in this series. So one thing we'll talk about to understand the difference between the tasks, the threads, and the processes, we'll need to first understand the different types of multitasking, and we're going to look at the two main types of multitasking. We're going to look at preemptive multitasking and cooperative multitasking. So we'll first begin by understanding what preemptive multitasking is. So preemptive multitasking, this is commonly used in threads, so we'll talk about this just as we go along. Also, don't know if you know what a thread is in Python. So threads are tasks that can be interrupted and stopped by the operating system at any point in their execution, and their progress saved and will be used whenever they get restarted again. So whenever you have a process that can be the operating system decides when to start the task, when to stop it, and is in charge of stopping it at any point in time, that is called preemptive multitasking. And if you want to read more about preemptive multitasking, I'm going to drop a link here to Wikipedia. It has a very good explanation of what preemptive multitasking is. So the other type of multitasking is known as the cooperative multitasking, and this is probably used in asynchronous programming, async-IO programming. In this concept, a given process does not get started or interrupted by the operating system unless the program itself announces when it's ready to switch. So in this preemptive cooperative multitasking, the operating system, the only task of the operating system is deciding when to start the task or not. Once the task or process gets started, then the operating system has no power to interrupt the program unless the thread itself gives back control to the operating system. So I have this definition from Wikipedia, and it explains more. In this scheme, the process of scheduler of an operating system is known as a cooperative scheduler, whose role is limited to starting the process and letting the process run, letting them return control back to it voluntarily. So the operating system can only start a process but does not have the ability to interrupt or stop a process unless the process itself gives up control. That is known as cooperative multitasking. In this way, the different tasks can cooperate by letting each other know when they are done using the CPU, so that another process can take over. That's why it's known as cooperative multitasking, because the tasks themselves are able to cooperate by communicating when they are done using the CPU, or when they are not in need of the CPU, and then another task can take over from there. That is known as cooperative multitasking, and this is what is used behind asynchronous programming. So in summary, threads and asynchronous program, async-IO multitask occur on the same CPU, and this is very important to notice because we'll go into multiprocessing, and this is very different from that. So as in threads and asynchronous programming, all the tasks occur on a single CPU or a single core. So let's talk about parallelism. Okay, I hope it's pronounced like that. So processes are passed by the processor, aka the CPU, having multiple. Okay, there's a typo there, so sorry for that typo. Multiple processes, meaning we can process more than one process at a given time. This is called parallelism. So basically, when you have many computers today, we have different CPU. We have CPUs having different cores, right? CPU have maybe 5 cores, 4 cores, something like, or 6 cores. So how do we make sure that we make use of all these CPUs properly, or make sure you make all this use of make proper use of all these cores as they are called. So basically what we do is that we have a process, and each process can run on a specific only on a specific core. So one per core, if let's say I have my computer has 4 cores, right, means that I can only run 4 processes at a given time, whereby each process is going to run on a different CPU or a different core. This is what we call multiprocessing, and this is different from threading and asynchronous programming, because threading and asynchronous programming, all the tasks run on a single CPU, and then you have this unique way of switching between the tasks to use the CPU to make the process faster. But in multiprocessing, each process runs individually on its own CPU. So if you have 4 CPUs, then you can run 4 different processes at a given time. Okay, that's what multiprocessing is. So running different processes, each process on its own CPU. While if you come to threads and sync.io, we are running multiple tasks, but on the same CPU. We just have a unique way of switching between them, which is we talk about cooperative multitasking and preemptive multitasking, right? Whether the operating system itself decides which process run and interrupts the processes, or the processes themselves are able to cooperatively communicate when they're done using CPU so that another process can run. But in multiprocessing, we are using each process is running uniquely on its own CPU. So I hope that makes sense. So how is parallelism achieved in Python? So you might have heard of something known as the GIL. So the GIL stands for Global Interpreter Log. This means that Python can have only one instance of a Python interpreter running on a given CPU or on a given core. This means that Python cannot perform multiple processes on the same CPU. So how does Python achieve parallelism? If parallelism, we need to run different processes on different CPUs. So what Python does is very clever. It's very clever. So what it does to beat the global interpreter log is that Python's instantiate the different instances of the Python interpreter. So that each CPU on the computer will be having a different Python interpreter. Hence, we'll be able to run different processes. That's how we achieve multiprocessing or parallelism in Python. So we just create multiple Python instances, and each Python multiple instances of the Python interpreter, and each instance of this Python interpreter runs on its own CPU. So this way we are able to achieve processing, since each CPU has its own Python interpreter, hence is able to run a given process. That way we are able to run multiple processes on different processors at a given time. So this is how we beat along the GIL. So I'm not going to go into depth about the GIL. It's a very complicated topic in Python. So if you're interested about the GIL, the global interpreter log, which limits Python to have only one Python interpreter on each CPU, you can go and read into depth about that. But in this tutorial, I'm not going to go into depth about the global interpreter log, or the GIL as it's called in Python. So now that we have looked at all of that, let's look at a summary of all of this. So preemptive tasks, the operating system is in charge of switching between tasks. So a number of tasks that process that can run at a given time is only one. And then cooperative multitasking, the operating system, the OS is in control of starting the task, and tasks themselves decide when to give control back to the operating system. In this case, you can only run one process at a time. So we have preemptive multitasking and cooperative multitasking. Both of these run on the same CPU. Okay, and then we have multitasking, which runs on different CPUs. So all tasks run at the same time on different cores or CPUs. Okay, whatever you might be calling them. So this run on the same CPU, but just have a unique way of switching between tasks. So this one the operating system decides. This one the process themselves decide when to give back control to the operating system. And then this multitasking, we have multiprocessing. We have different Python instances on different CPUs, and hence we can run different processes on different CPUs at a given time. Okay, so now that you have looked at that, I'm going to leave this link to Stack Overflow. It really gives a great understanding of multiprocessing versus multitasking versus asynchronous. So if you want to read in depth, I'm going to leave this link there. I'm going to put in the description so you guys can read about it. So let's go and talk about asynchronous versus synchronous programming. So in synchronous programming tasks, we performed one at a time and only when one is completed, the following is unlocked or performed. So meaning that whenever you're on one processor, right, because it's a synchronous program, async.io, right, it only occurs on one single processor, and only one task can run at a time. Once that task is done running, that's when another task can be run. So we can have two different tasks running at the same time, because it is only on a single CPU. In asynchronous programming, you start performing another task before the previous one completes, meaning that whenever a task is done or is waiting for something to be done, maybe reading a file, is waiting for the file to respond, or is downloading and maybe downloading an image, right? You make a request to a server, it takes some time to return a response. So instead of just waiting, that task occupying the CPU and just sitting there and doing nothing, waiting for the network to respond, in asynchronous programming, you have a unique way of switching between tasks. So once the task is waiting for the network to respond, another task can go ahead and also begin to perform its stuff. Maybe you're downloading a bunch of images, as we'll see, right? So when you're downloading an image and one process goes there and to the CPU and make a request and is waiting for the server to respond, it can give control of the CPU to another task, and that task can also make a response to the server to get an image. So whenever the first we get the response for the first task, then the first task goes and takes control over the CPU and then receives that image data and does whatever it wants with it. And then if the other response also comes back, we also switch the other task to go and receive that response and does its processes. So that's what asynchronous programming is. So asynchronous programming is used when we have tasks that do not depend on each other. For example, downloading images, they don't depend on each other in any way. So one image download does not depend on the other image download. And then we have a synchronous program. Synchronous programming is used when we have tasks that depend on each other. Maybe we are trying to divide a number and then pass the result to another process to do something. These tasks depend on each other because the output of the one task is used in another. So one task must get completed before another one gets started. So that's what that's when we use synchronous programming, and this is what we use most of the time. So now also go ahead and talk about IO bound tasks. So these are tasks in which the process must wait on input and output from the external sources such as files, file systems, input from keyboard and internet connection in order to work. So if you have anything dealing with IO bounds for input output bound tasks. So for example, again, you're trying to download an image, right? So you're making a request to a server. That server takes some time to respond. So the ability to process, the rate at which you process that task depends on how fast the network is and how quickly you are able to receive the response from the network. So that is an example of an IO bound task. Example, if you're also reading a file from a file system, the ability of the process, the rate at which they process, the speed of the process depends on how fast you're able to read the file, right? It's an input output bound task. And if we come to CPU bound tasks, these are tasks that do not depend on input and output factors such as network services or input from keyboard or file system. So these are the only limiting factor is the CPU itself, how fast the CPU can process the task that we have for it. So that's the only limiting factor. So now that you have looked at IO bound and CPU bound tasks, let's take a good example of what an IO bound task is. So I'm going to go into my terminal and then we're going to program this. One of the things, we are going to create a virtual environment. So this is a command to set up a virtual environment in Linux. If you're on Windows, this is the command to set up a virtual environment. And if you're on Linux, this is the Linux or MacBook, this is the way to activate your virtual environments once you have run this command. Again, I'm going to leave the link to the Python official documentation which tells you how to create a virtual environment. If you're not interested in creating a virtual environment, then feel free to skip this step. You can just go ahead and move to the second step, which is to install the request library. And to install the request library, what you need to use is this command right here, pip install request, and this is going to install the request library on your operating system. Once that's done, we can go ahead and begin to programming. So let me go ahead and actually create a file which we're going to keep our Python file. So I'm going to create a file here called Concurrency. So instead of this file, I'm going to go ahead and actually create a virtual environment. So let me just deactivate my Conda environment for now. So Conda deactivate. Again, if you don't have Conda installed, feel free to ignore this step. So I'm going to change my directory into my Concurrency environment. And then you can see right now I have nothing inside. If I do an ls on Windows is dir. Or you can just create a normal file using the Windows GUI or stuff like that. Okay. So now that I'm here, I'm going to create a Python virtual environment. I'm going to python 3-m venv and then venv. Okay, this command will only work for guys on MacBook and Linux. So if you're on Windows, again, read the official documentation. Okay. So if I do an ls, you can see that virtual environment is created. To activate the virtual environment, if the source venv/bin/activate, and this is going to activate the virtual environment, and you can notice the name of the virtual environment folder in parentheses in front of the line within the terminal. That shows that your virtual environment is activated. All of this is on the Python offshore documentation depending on the operating system, so I'm going to leave a link to that documentation. So now let's go ahead and import and install this library, the request library. So I'm just going to paste this command here, pip install requests, and that is going to go ahead and install requests in my my virtual environment that I just created. So now that we have requests installed, I'm just going to go ahead and open up my Visual Studio Code. So let's just wait for Visual Studio Code to open up, and then from there we can begin to code. So you can see now my Visual Studio Code is already open up. So I'm just going to go ahead and create a folder here. Sorry, not a file. I'm going to create a folder, and this folder I'm going to call it program file. So let me just create a folder. I'm going to call it program files, just like that. This way we're going to keep all our program files. So in here I'm going to create a file. I'm going to call it io underscore bound.py. okay, and this way we're going to create an io bound task in here in this specific file. So let's just wait for that to open up, and it's open up. So let's go ahead and import all the things that we need. So I'm going to import the request, because you're going to be using the request library that is used to make requests in Python. So we're going to use that to download a specific you're going to download a bunch of images. Okay, so I'm going to get the URL for these images that you're going to be downloading from my GitHub page, and this link I'm going to put this in the description below in case you guys want access to this this link here. Okay, this file right here. So I'm going to go ahead and actually paste that in here. So this is a bunch of images that I got from Pixel. So I'm just writing the create a dictionary having two keys, the URL, and its value is just the URL, and then a type. It is a type of the image that we'll use in naming the image just in a second. So as you see, so I'm going to go ahead and create a task. So the first we're going to create a function. I'm going to call download. I'm going to call it download underscore images. Okay, this task is going to be responsible for download the image. So download an image. So it's going to take an image underscore data that you want to download, the data of the image that you want to download. So I'm going to go make a request. So I'm going to say response. This is going to be request dot get. I'm going to put image data. Since this is going to be a dictionary, I want to get the URL part of that image. So I'm going to pass here request.get. You have to pass in the URL that you want to get, and the URL that you want to get is going to be the URL key of that image, which is going to return to us this URL, okay, which goes to Pixel. Okay, so once we get that, I want to go ahead and I'm going to say create a file. So I'm going to say file. I'm going to create a file name underscore name, and this is going to be, I'm going to generate a random name for my image. So I'm going to have a folder called images here. So I'm going to create a folder in here called images. So I'm going to create a folder called images just there, and then in here I'm going to refer to that image. So I'm going to use an f string, and I'm going to say a dot / images / and then I want to generate a random token to be used as our image. So I'm going to go ahead and import secrets here. So it says from I'm going to say, I think just say import secrets, just like that. And I'm going to come in here, and don't need to install secrets for this to work. So I'm going to say secrets dot token hex, and I'm going to pass in a secret of token hex of 20. So I'm going to generate a series of 20, or let me just keep it to be 6 so that is not so long. So I'm going to put 6 here, and then I'm going to say that's the name of that image, and then I'm going to say dot, and then I'm going to pass in another parameter here, which is going to be image data.get type. Okay, type. So we're going to have a random token to be the name of the image. So let me just explain to you. So the random token will be something like this, and then I want to have dot, and then the image type, and the image type specifies or let's say JPG, image, PNG, or something like that. So I'm going to have, in my case, I'm going to have JPG here. That's what I'm trying to achieve by using this syntax. So image data.get, and I'm going to say I'm going to get the type. Okay, and this is going to be single quotes because I use double quotes on the outside. Okay, I got that wrong here, so it's going to be there. So now that we have that, this is generate for us a random hex token for our image file. Then I'm going to go file. I'm going to open up that file. I'm going to open it up, and I'm going to generate. I'm going to say file. file underscore name, just like that, and I'm going to specify which mode you want to read the file. I want to read in write binary. Okay, because you're going to write in binary to a file, I'm going to this file dot I'm going to write to it. I'm going to write the response dot content. Okay, the content that is going to come from the response, and then I'm going to now file dot close, right, close that file after writing it in there. That's a good practice to always, if you open something, make sure that you always close it up. So that's the function that is going to download the images for us. So let's create an entry point to our program. If name, sorry, if name equals to this is going to be underscore main and underscore, and then you're going to do we're going to now import time, because I want to check how long this takes, because the main purpose of this is to go, the main purpose of concurrency is to improve speed. So I want to measure the performance of our code along each time as we go along. So I'm going to import time. So I'm going to say import time, just like that, and I'm going to come down here. I'm going to move down here. In here I'm going to say start underscore time, and this is going to be time dot time, just like that, and I'm going to call this function here. So I'm going to now pass in a I'm going to do a list comprehension. I'm going to say download image, and it's going to take item. I'm going to pass in item, and I'm going to do for item in file URL. So for item in file URL means for each of these items I'm going to pass it in here. I'm going to call this function and pass it in, which is going to call this function, and then get the image URL, which is going to be here, get the image URL, and then also the type, and then download the file for us. So now I want to also check the duration. So duration, once that task is done, I want to get the time again. So with the time minus, I'm going to calculate the time and start time. Okay, so this will return to me how long it took. So I'm going to now go ahead and print it, and I'm going to do an S string here. I'm going to say time taken was, then I'm going to print that time here, and I'm going to say this is going to be in seconds. So I'm going to say duration, and then space seconds, just like that. So this is going to now do a list comprehension, call this function for each of these dictionaries in here, pass it in here, download the image, and after that to get back the time it completed, and then we'll print that out. So that's basically what you're going to do. So I'm going to go in here, do an ls, change my directory into program files, and in my program files I can see I have that Python file there called bound, the io.bound. So io.bound, okay, io.bound task. I'm going to do Python 3, and then so this will be io.bound task, and then I'm going to run it, and let's see how long it takes to download those images. So we are still waiting, and let's see how long it takes depending on my network speed. Yeah, so you can see it took about 8 seconds to download those images. So let's actually check if the images are indeed downloaded. So if I do this, check the images, you can see I downloaded this image, I downloaded this image, and I also downloaded this image, and I also downloaded this image. So it took us about 8 seconds to download the images. Okay, can we improve on this? Yeah, we can improve on this, and let's go back to our slide and let's see what we have in here. So this is a synchronous program that you have just done. It's known as a synchronous program. This program is very intuitive to, it's very simple to understand, because you don't have to think about task switching. You just have the logic, and the flow of the logic is much easier. So it's easier to understand and debug. So that's a synchronous program. Okay, let's look at how you can use threading, multi-threading to speed up this. So I'm just going to create another file in here. So I'm going to minimize it, create another file. I'm going to call it io bound. I'm going to say concurrency.py. Okay, so inside of this file you're going to go ahead and actually learn how to speed up this program. Okay, so I'm just going to go ahead and copy everything from here. So I'm going to say select all of this, copy it, and then move it inside of this file. And in here, I'm going to use concurrency to improve this. One thing you can write another function to do this. So we can say download underscore images underscore concurrently. Yeah, I hope that's the spelling of concurrently. So I'm going to take in a file underscore URL. And what you're going to do, you're going to now use futures. So if you you should be using Python 3.5 and above, I believe. So we're going to say import, because this is only available in Python 3.5 and above, I think. So concurrency, I'm not really sure about that, so I'm going to say concurrency.futures. But this is a Python library that you already have to do multi-threading in Python, so make sure that you import that. And then down here I'm going to do a context manager. So I'm going to say with concurrency I'm going to concurrent dot let me see, concurrent.futures. Anyway, I can just go ahead and actually import concurrent here, and then I can do concurrent.futures. I'm going to do dot thread pool executor. So I'm going to get the thread pool executor, and I'm going to pass in the maximum underscore worker. So maximum number of threads I have. I want 5 threads. And then I'm going to do let me just use, I think I have 3 images. Let me check the number of images I have. I have 1, 2, 3 and 4 images, so I'm going to have the number of workers to be 4. Each worker will deal with 1 action. So execute as executor. Then what I'm going to do, I'm going to do executor dot map, and I'm going to pass in here download images, and I'm going to pass in the file URL. So for what map does, I hope you understand the basics of map. I'm not going to explain what map does basically. So but what basically does, it takes each file URL and then maps it to a given this function. So for each of these file URL, it's going to call this function and pass in that file URL, and it's going to execute that. You're going to have 4 workers in this process. So now instead of I'm just going to go ahead and try remove this part, and here I'm going to simply call download concurrently, images concurrently, and I'm simply going to pass in my file URLs. So that's all I'm going to pass in. So what this is going to do, file URLs, and just files URL, I think, what did I call it? Let me just go here and get copy this, and then change it in here, Control V. So what is basically this is going to do is going to call this function, and this function is going to take in all the URLs, and then it's going to go here, it's going to map to each URL. It means it's going to match for each dictionary in here. It's going to call this function here, and then pass in the dictionary, and then perform this process of downloading the file. So this is how we achieve multi-threading in Python. So let's explain to you a bit of this. So thread part of this multi-thread pool executor, the thread part will generate the thread. The pool is a collection of threads, and then the executor is responsible for knowing the state of the threads and which thread is running and all that thing. So in normal thread, if you're programming traditional threads in Python, we have this thing of queues to start. So this executor is the one who manages all the processes, knowing which thread is running, when to start another thread and stuff like that. So that's basically it. So now let's try to run this, and let's check the performance of this. So I'm going to do Python 3, and this will be IO bound, and then underscore concurrency, and then let's run this. So we have an attribute here, concurrency.futures. So let me see, have an error here. So let me see where we have done the error. So let's go back here, concurrent. Let me just say concurrent.futures. Let me just say that, and let's see concurrent.futures. Yeah, that's basically it. So let's try to run this again. Hopefully I haven't made any error. So yeah, this is running, and let's see how long it takes to download those images. So it took 3 seconds to download those images. So if you go back in here and you check the image file, you can see we have more images in here additionally added. So you can see the images have repeated themselves. Yeah, so that's basically it for how we can use concurrency to speed up the data. Before we end this tutorial, let's go ahead and actually run this process. I want to delete some of the files in here before I download a new one. So I'm going to say dir is going to be /images, and then I'm going to do for file in os.scan, yeah, and I'm going to pass in the current directory. What I'm simply going to do is get let me just go and actually import os. So I'm just going to say import os, just like that. And what this simply does is going to go through all the files in here, delete them before running this, so that we don't have too many files in there. So I'm going to say os.remove and I'm going to pass in file.path, just like that. So this is going to delete all the files each time before we run our process. Let's run this one more time. So let's wait for this to complete, and you can see that it has completed. It took about 3 seconds. So you can see that using an IO bound task took 8 seconds, and using the multi-threading, we split that time in more than half, so it took only 3 seconds. So you can see how that is really beneficial. So now that you can see that we have only one file, so you can check the images have been downloaded. This one downloaded, this one downloaded, and you can see we have only 4 images because we have cleaned the images directory before downloading new images. So guys, that's all about multi-threading in Python. So in the next tutorial, we'll talk about multiprocessing, how you can use multiprocessing to speed up this task even furthermore. So thanks for watching. See you in the next one. Keep safe.